Well, good afternoon, everyone. My name is Ben Villarreal, and today we will be going over Menards Cisco voice log automation for our spring 2023 Capstone group. So as you may know, I'm going to address the elephant in the room right now. There is no Matthew Barton. He is currently sipping on pina coladas and enjoying a nice poke bowl as he enjoys his annual training out in Hawaii with the United States Naval Reserve. But I do have, thank you. But I do have the rest of my associates here. This guy right here, Ross Barnett, he was our lead Splunk engineer. He's the guy that was the driving factor and the reason why we got the majority of the Splunk stuff done. I got Elias Bates right here, right next to him. He's the guy that was in charge of implementing our Cisco, our CME. Guy to the right, to the left of him, excuse me, is our cube configuration guy. He's also a systems engineer. Hayden Ballard, also one of our systems admins. He was the one that was in charge of implementing the network. And then we have our prime Cisco Unified Communications Manager, Marcos Iltran Ramirez. I know I said that wrong. I'm sorry. So our background of the current situation, hate the clicker. The background of the current situation right now is that Menards, as we all know, expands to more than 7 states within the United States. And the issue that they are currently facing is, in a wide area network, your phones are always consistently going down. When your phones are going down, you need to have a way of troubleshooting it. The only way that they currently have to troubleshoot it is to actually travel to that site and figure out a way to what's going on. There's an issue with this because, number one, when you got a lot of manufacturing plants, when you got stores, when you just got distribution centers wherever, traveling, it can get not only expensive, but it can take a long time before another call issue happens and you're finding yourself running back and forth. So what we were tasked with was to find a way to aggregate all the call log data that was implemented from different call managers and put them in to multiple Cisco VoIP platforms, which we in turn got into Splunk, which we will go over here in a second. So our presentation's objectives today, we're going to show you our network topology, our Cisco VoIP platforms overview, our Splunk overview. We're going to give you a live demonstration, and hopefully by then we'll have some room for questions. So for our network topology here today, we decided to keep the network pretty simple. We ran one ESXi server that had 2 virtual switches. One of them ran the CUCM VM, and another one ran Splunk. And then on the other side right here, you may take notice to the simulated WAN VM. Again, its name implies what its task does. It's supposed to simulate the packet flow that you'll see in a normal wide area network. And you are actually able to cause issues within that wide area network. And then we just had 2 physical routers, 2 layer 2 switches, and then we had phones on both sides. And right now I'm going to turn it over to Hayden.
So we used 2 VoIP platforms to actually facilitate phones in our network. One was CME, which is essentially just a lightweight variant of CUCM, which we also used. CME, you can actually set up on any given router. It just takes a couple router commands. It's super simple, super lightweight, and we essentially used it to both router phones into the network and assign them IP addresses. But I'll let Marcos go into more detail on CUCM.
So yeah, me and Eli worked greatly on CUCM. The focus on this project was aggregating the log data from CUCM, so we actually kept the CUCM configuration pretty fundamental. We have phones, users, and everything that was needed to make calls happen. However, there are 3 features of CUCM that I want to talk about that are extremely important in this aspect. The first 2 would be Cisco CDR and CMR. These are features Cisco built into CUCM. They stand for call data records and call management records. CDR does everything, logs everything about phone calls from who called, how long they called, where they come from, and everything like that. CMR is a little bit different as it focuses on the quality of the call. Was the call laggy? Was there a lot of jitter? Did the call even ever establish? Those 2 are responsible for getting a lot of the data to Splunk. And then the last thing I have to talk about would be the SIP trunk from CUCM to the cube router. This is so our VoIP platform can actually call other VoIP platforms. And the SIP trunk is essentially like a virtual phone line. Rather than having a physical one, we kind of moved past that. The SIP trunk takes CUCM phone calls to the cube router, and the cube router can communicate with CME.
Okay, so for our configuration for the cube routers, our initial configurations don't send enough data for call logs for Splunk. So we had to add a couple more lines of configurations so that we can get a more detailed call report. So on the first image you'll see is the 2 extra highlighted lines of commands we added to add more detail to the call detail reports. Now for our normal router, here on the second image here, we have highlighted commands that will also kind of collect data and then send it out to the FTP server.
So before we get into a greater Splunk overview that Ross will be doing here today, I'll talk about a little bit about some of the stuff to help us achieve our aggregating goals. So we use FileZilla here, which is an open source software that sends data, sends cube and CUCM data over to Splunk. And then we also use SideView CDR reporting for the cube and CUCM CSV files, help index and label them. And we also use Cisco network add-ons for Splunk Enterprise to help index the rest of our Cisco devices and products. And then the top right here is the raw data CSV file, and then on the right here is what it looks like after it's indexed and labeled.
So to add on to what Marcos and Eli talked about, that diagram on the right side of the screen up there is kind of just a quick overview of our data flow in our network. Marcos had mentioned CDR data, CMR data, and cube CDR data. These are the 3 main primary types of logs that we're ingesting into Splunk. Thanks to Cisco, cube data can only be sent over FTP. CUCM allows you to use SFTP as well as FTP, but cube data can only be sent via FTP, so that's why we chose that protocol. And that's why we're sending all of our data to one single server. Our FTP server actually lives on the same server as our Splunk VM, just to save resources. So one of the main things about Splunk is it has Splunk indexes. Indexes I kind of like to think of as databases. It's more of a way to separate that data when it's ingested into Splunk. Eli had mentioned that we're using a plugin called Cisco CDR Reporting and Analytics. What this plugin does is when it pulls that data into Splunk, it comes in that raw CSV file, hard to read. It labels all that data with variable names, or Splunk calls it fields. So just a little bit easier for later on when we do our queries and pull that data out, we have data labels on that data. For our indexes, we have 2 indexes. We have Cisco CDR and we have Cisco syslog. This is more of a way to also separate our data when we're running our searches. So if we do a search later on, we're not looking through also syslog data in addition to CDR data. Kind of cuts down on CPU and resource usages. And then also a thing that Splunk does is it separates by source type. This is another thing that plugin that we use does. When that data comes in, it labels it based on the file name and then source types it. So we have CUCM CDR, CUCM CMR, Cube CDR, and then Cisco iOS. This is just for standard Cisco syslogs. The other 3 are from cube routers and CUCM. And when it labels it, this is kind of just another way for when we do our queries later on that we have a way to specifically look at just CUCM data or just cube data rather than having to parse through and look for a huge data set with millions of logs. Because in an enterprise environment, you're going to have a lot of phones, a lot of log data going into that location. And then, so that was just a little bit of an overview of how the data is actually sent over and ingested into Splunk. The main driver of Splunk is Splunk searches. The main utility of Splunk also is to visualize that data and have a better understanding of it rather than just looking at all the raw log data. So Splunk searches is what drives that visualization. So this is an example of a Splunk search that we have for our dashboards that we'll demo later for you. That top section is kind of the main driver. This is where you're looking for your data. So we can see index equals Cisco_CDR. We're looking in that specific index, and we're specifically looking for the cube CDR source type, just to limit all of the databases that we're looking at. Again, cut down on search time. That second section down there this is what makes Splunk stand out a little bit from SQL in that you can manipulate data as in your query. You don't have to use a third party. So those eval statements there are just taking the time from the log and converting it to a more human readable format. And then that second highlighted area is the second, like the main function that you need to have in a Splunk search. This is the where command. This is where you're doing your filtering for your data, where you're telling your Splunk search what you want to look for and what to exclude when it returns those results. In this case, we're actually passing something called the Splunk token. On Splunk dashboards, you have the ability to have data inputs. So if you, for example, type in, I want to look for phone number 1004, that passes it to the Splunk search through Splunk tokens, and then passes it into this search, and then you can filter it based on that. And then there's more, just an eval command down there, and there's also a regex command. One of the things that our plugin does is it doesn't handle CME log data very well. So you have to manually use regex to parse out that data from the raw CSV file. So regex just looks for anything that has any search or any log data that has CME in it and pulls that out. In that bottom section down there where it says table, this is where you're actually defining what Splunk should do with that data. How do you visualize it? In this case, we're using a table. Splunk has all kinds of different visualizations. You can do pie charts, you can do bar graphs, all kinds of other stuff. But in this case, we're just using a table. And all of those variables or Splunk fields to the right of it are actually what we're going to display in that table. And this is what Cisco CDR is doing when it's ingesting the data. It's labeling it with these data labels, and then we're telling Splunk to pull that data out and put it into a table. And the rename section down there is just a way to rename columns so it looks nice on the actual demonstration. So we're going to go into the live demonstration here of what our Splunk dashboards are. Let's do that. So when you log into Splunk, this is just the home page here. This is what you'll be greeted with. You can set a default dashboard on the home screen. In this case, we just have our main dashboard, but we're going to actually open up a new tab here. If you click on this button here, it'll open up, it'll expand that main dashboard on the screen. I have it open in another tab just to save time because it takes a little bit to load. So this is our main troubleshooting dashboard. The goal of this dashboard is more of like an enterprise overview of the entire VoIP infrastructure, not just necessarily one call for troubleshooting start to finish. A good use case for this is maybe you want to see the average call volume for that specific day. So at the top here, on the top left, you can see this filter for global time range. You can go pretty detailed with this. You can look at specific hours of the day, specific dates of the week, or specific days of the month, whatever. We're just looking at historical data from the last 30 days, calls that we were making while we were testing and building this infrastructure. And this first graph on the left up, on the left up here, is failed and completed call counts. So the back end of this is actually running a Splunk search, and it's going through that log data, and it's pulling out, and it's labeling any call that has a duration of 0 seconds considered a missed or a failed call because the call never completed. And then anything that has a duration higher than 1 second is considered a completed call. And then this graphic in the middle here, this is just the latency of the entire VoIP network. May not be super useful, but later on when you're troubleshooting, maybe you don't know what a good phone call would look like or what your average latency of your phone call is. This would be a good way to go look, oh, hey, okay, it's 4.4 milliseconds. This pie chart on the right here is more of a detailed look at those calls that occurred in the last 30 days. When a call disconnects, Cisco actually gives a call disconnect code. And that disconnect code is usually just a 2-digit number. And it's also, and if you go on the Cisco documentation, it's associated with a specific type of error. So in this case, the majority of our calls have normal call clearing, 82% of them. You can also see that there's 13% of the calls that generated a network out of order call code. So this would be useful if you're maybe having more of a, not an isolated issue, but you're having more of an enterprise event issue. Now you can see, okay, maybe there's a lot of network out of order calls coming in. So there's more than just an isolated issue. This second graph down here, hide that. This is more of a trend to use to visualize the average jitter in your network. We can see on the left side we have a jitter of 0 because we're running a very small network, so very low latency. But on the right side we can see we simulated some calls that had pretty high jitter, 380 ms, that you're going to have a bad quality call with that. So you want to see the graph kind of sloping down to the right. It's more of just another way to indicate the overall status of your enterprise network. And then this table down here, not so relevant for troubleshooting or anything like that. It's more of a way just to ensure that you are actually ingesting log data, because this is just a log of all recent calls in the last 30 days. It does give call connect time, call disconnect time, but the focus for looking deeper into calls will be another dashboard. This is more just to see that you're actually getting the logs and Splunk is seeing that these phone calls are occurring. So if we scroll back up to the top here, there's this button up here called Deep Dive. I have the tab open, but if you click on that, it will open up another dashboard, which we're calling the Call Deep Dive dashboard. You can see right from the start, I have it filtered from April 25th to April 28th. We made some test calls this day and introduced latency, introduced network issues. So that's why I'm specifically filtering for this time. And we also have this call from, call to. This is another way. So let's say we have a user that calls in and we know their phone number. We can filter all of this UCM log data for that day for specifically just that phone number. So we're not looking through pages of log data. It's easy to find. One thing about Splunk is they use the percentage as their wildcard instead of an asterisk like most companies. So right now we're using 2 percentages, which just means we're looking at every single call that occurred on that day between that specific time range. So then this is the actual table that is going to provide information about a call. I clicked on this one here. Our hard drives on our server are a little slow, so it does take quite a while to run a search. So I have one built ahead of time, and then I'll also click on one later and show what happens when you click on a bad call. So you can see this call occurred from this phone number 1003, which was on our left side or CUCM side of our network, and it went to 2112, which was on our CME side of the network. We can see the time that the call was connected and the time that it was disconnected. One thing to note is that Cisco does everything in GMT time, so you'll have to add 5 hours. And then this is just the duration of the call. So like I said before, this is kind of what that chart was based on. And then one other thing you can see here is you can see the calling user. So maybe you have somebody calling internationally that shouldn't be calling internationally. You can view, okay, this was the user that made this call at that time. And you can also see the called user. This would necessarily only work if you're making internal calls, because you're not going to see that other side of the CUCM log. In this case, we're calling to a place where we have logs from both sides, so we can see both calling parties. And then this call ID, this is just how we associate it, because when the logs come in, they come in separate. We have our CDR logs and our CMR logs. So how do you associate those 2 logs together? We're using the call ID to do that, because those are the same between those. So when you click on the call, it'll actually give you these details about the call on the right side. These are all pulled directly from CMR log data. So at the top here, we can see, okay, the overall general status of this call was it was great quality. It gives just a breakdown of jitter status, latency, packets sent, packets received. So if you have any network issues, you'll probably see them arise here. You'll probably see, okay, maybe we have high jitter. And then here's the call codec. When a call occurs, it negotiates an initial codec. Sometimes you can have a codec mismatch if something's misconfigured, or if you have a phone that's not the same on both sides and they don't play nice with their codecs. So this is a good way to troubleshoot that. We can see, okay, this is the codec that should be negotiated, but what was actually negotiated is not correct. And this partition, this is another good way to, maybe if you have somebody calling internationally that shouldn't be, they completed that call, so now you can look at why did they complete that call. Oh, maybe they were in the wrong CUCM partition. So just another way to troubleshoot that kind of stuff. And then Cisco also provides something called K-factor data, which is just really a real specific deep dive into the status of the call. Just a quick overview, CCR is concealed call ratio, ICR is incremental concealed ratio, ICR-MX is just a shorter span of that. It's looking at the last 3 seconds of the call. CS is concealed speech, and then SCS is severely concealed speech. Cisco doesn't give a whole lot of data on how those metrics are calculated, but generally, if any of them are high, it's bad. For concealment ratio, sometimes we'll see that even on a normal call. That's just a matter of the quality of the phone that they're calling on. So severe concealment ratio is more what you want to look at if the call quality is actually bad. And then one of the things that Menards had stated that they're having trouble with is how do you associate the cube records with the CUCM call? Because when a call starts in CUCM and then it hits cube, it also generates a CDR. But how do you figure out to associate those logs together, because there's no uniform call ID between Cube and CUCM. As soon as it hits the Cube router, it changes the call ID number. So what we're doing is we're basing it on call disconnect time and also the called party and the calling party number. So we're verifying that. So this is more of a way to view the logs in one location rather than having to look in multiple spots. So here we can see incoming. The left side is incoming and the right side is outgoing. When you have a call, you establish two SIP trunks. You establish one for incoming, one for outgoing. And when they're established, they actually use different protocols. And we'll see that come into play in a little bit here. But this is just another way for more details on if you need to troubleshoot a call from start to finish. Now you get the full picture. It hit this Cube router. And where it's going, we can see again the disconnect cause. Maybe you're getting a different disconnect cause at the Cube router than you are getting at the CUCM router, or the CUCM server. So just another point of data. The protocol that was negotiated, and then the UDP port. This is an important one because you could have a misconfiguration in the firewall, and then you'll be able to see this here. So if we scroll down, this next section is router iOS logs. So let's say we think that the router, or that the issue is on a specific Cube router, but we don't want to, we're already in this interface, so we don't want to go out and look and do a show logging command on that router. We can actually, as long as we're sending syslogs, we can actually view them directly on this interface. If we just go, oops. We go to this router. This is the HQ side, so the CUCM side router. If we scroll down, it'll take a little bit to search, and then it'll pull it up. So if we had, if we go back up here, one of the things that we were demonstrating before is we'll see calls that have a network out of order cause description. This just means that the call had nowhere to go. CUCM got the call and it forwarded the call, but as soon as it hit Cube, the call was dropped because Cube didn't know where to forward it, or couldn't forward that to establish the SIP trunk. So we can assume that probably was because we had an EIGRP neighbor adjacency failure and the interface was flapping, so it couldn't establish that adjacency. And then if we go back here a couple pages, this is one of the calls that we did a live demo on. So let's say we had a user call in and only one side of the phone call is operational. You could hear them, but they couldn't hear you. So if we click on this log, we can do kind of a deeper dive. It'll take a couple seconds to load here. But one of the things to simulate this is we put an ACL on one of our routers, and we just blocked outbound traffic for UDP port 5060 on one side. So we still have the initial negotiation, because when SIP negotiates a trunk, it uses a different protocol than when the phone call is actually established. When it's established, it uses UDP port 5060. When it initially does it, there's a wide range of ports that it can use to establish. And you'll see that down here when it finally populates. That we only have Cube log data from one half of the network, and that's because it died in the middle. Oops. So we can see the outbound side loaded, so we can see we only have outgoing traffic. The call did establish, and it did cross the WAN because we know it went from 2111 to 1003. So why are we only getting log data from one half? That's because only one half of the call transaction was successful. So really the main use cases of Splunk are going to be just an aggregation point for the data. I mean to minimize there. Just an aggregation point for the data. You can view everything in one location rather than having to log into each individual device to view all of your troubleshooting needs. All right, thank you everyone.